All right, continuing off of last time, we're solving inequalities and then graphing them on a number line. So let's take a look at number 11. I know I said number 11 because I actually planned on doing this in the previous video, but I was looking at the clock and it was getting a little bit long, so I figured I'd save it for the next video, which is today. So for the sake of argument, this is the first problem. So 4 is greater than or equal to 1/7 of x. So in this case, the x is on the other side of the problem. So I'm just going to give you 10 problems today on, just to ease your anxiety, when x is on the other side of the problem. Fear not, we're trying to isolate the x. So if 4 is greater than or equal to 1/7 of x, let's just pretend it's an equal sign. If this was 4 equals 1/7 of x, how would I solve for x? Well, I need to get rid of that 1/7 of x. So I would need to multiply both sides by 7/1, or 7. Sorry about that. Let me make the lighting a little bit better. There we go. Much better. Okay, so now 7 times 4 is greater than or equal to 7/1 times 1/7 of x. So the 7 cancels out, leaving me with, remember, I multiplied both sides of the equation, of the inequality rather, by a positive number, so the sign stays the same. So now I've got 28 is greater than or equal to still x. And now, even though this is technically how you solve for x, I kind of like it when the x is on the other side. Remember my analogy, where if you start the sentence with with the subject, you can always use taller or shorter, depending on who is starting the sentence. So if 28 is greater than or equal to x, start the sentence with x. So if 28 is greater than or equal to x, that would mean x is less than or equal to 28. So that becomes the solution set. Now, how do I graph this on a number line? Well, I started out with putting 0 in the middle. Where is 28? To the left or to the right of 0? Put it to the right. And remember, x is legally allowed to be all values less than or equal to 28. So I put a big fat dot on 28, and the numbers less than 28 shade to the left. And once I reach the end of the number line, I put a big fat arrow to infinity and beyond, or in this case, to negative infinity and beyond. And because the solution set says x is less than or equal to 28, is 28 actually invited to the birthday party? Yes, 28 is invited to the solution set birthday party, so we fill that dot in. Make it obvious. Okay. All right, second problem. 63 is less than 21x. So x is on the right side of the equation, of the inequality rather. So how do we solve, if this was 63 equals 21x, how would I solve for x? This time I'm going to divide both sides of the inequality by 21. Now, since I've divided both sides by a positive, the inequality is still true, so the sign stays the same. 63 divided by 21 is 3, which means 3 is less than x. But that's kind of confusing to me. I kind of like it when x is on the left side. So let's rephrase the problem. If 3 is less than x, I'm going to start the sentence with x. If 3 is less than x, x is blank compared to 3. X must be greater than 3, and then it's easier to graph. So I put 0 in the middle. Where is 3 compared to 0? To the left or to the right? To the right. So I put 3. Sorry about that. Let me hold that in place. There we go. So now that 3 is on the right side of the number line, X is legally allowed to be any real number as long as it is bigger than 3. So I put a big circle on the 3, and I'm going to shade all values greater than 3. So that would be to the right. I put a big fat arrow to point that my legal values of X can go to infinity and beyond. However, 3 is my endpoint. Look at the solution. X is greater than 3. Is 3 itself invited to the birthday party? No. 3.1, 3.01, 3.0001, just barely above 3 is invited to the birthday party, but 3 itself is not included in the solution set. Okay. Number 13. 90 is greater than or equal to negative 9x. How do we solve for x? If this problem was 90 equals negative 9x, what would we need to do? We would need to divide both sides of the inequality by negative 9. So 90 is greater than or equal to negative 9x, which means we divide both sides by negative 9. Hold on. Divide both sides by a negative, that sign needs to flip. So even if you make a little note to yourself, I like to do that because I'm forgetful. Divide by negative, the sign flips. So this is going to be negative 10 is actually going to be less than or equal to x. Sorry to make you flip it again. I kind of find it confusing when x is on the right. So if negative 10 is less than or equal to x, another way to write this would be to start the sentence with x. If negative 10 is less than or equal to x, well then x must be greater than or equal to negative 10. Therefore, I can draw a number line, 0 in the middle. Negative 10 would be on the left. What numbers are greater than or equal to negative 10? To the left or to the right after I draw this big dot? Greater than means I shade to the right. And since the arrow goes to infinity and beyond, I make it clear. Now, x is greater than or equal to negative 10. Is negative 10 itself included in the solution set? Yes, greater than or equal to means that negative 10 is legally allowed to be in the solution set. Or if you go into Algebra 2, this is a simple topic known as domain. What are the legal values of x? Okay, let's take a look at number 14 now. Negative 50 is less than or equal to negative 5x. Okay. If this was an equal sign problem, how would I isolate x? I would divide both sides of the inequality by negative 5. That cancels out, leaving me with negative divided by negative makes a positive, so that'd be 10. And remember, since we are dividing both sides of the inequality by a negative number, this has to flip from a less than or equal to sign to a greater than or equal to sign. So in this case, 10 is greater than or equal to x. But since x is on the right side, that kind of confuses me. So if 10 is greater than or equal to x, I'm going to start the sentence with x. 10 is greater than or equal to x means x should be less than or equal to 10. So according to my number line, x is allowed to be any real number as long as it is less than or equal to 10. So I'm going to put 0 in the middle. I'm going to put 10 on the right. And then I'm going to circle that 10, and I'm going to shade all the legal values less than 10. Anything shaded makes the above inequality true. So just to test it out, if I plug in 9, Negative 5 times 9 would be negative 45. Technically, negative 50 is less than or equal to negative 45. Negative 50 is less than negative 45. But if I go just one step further to the right, let's go with 11. Negative 5 times 11 would be negative 55. Negative 50 is not less than or equal to negative 55. That would be a false statement. So anything that's shaded is true. One last question. X is less than or equal to 10. Is 10 itself included? Yes. Less than or equal to means that the endpoint is included into the solution set. Because if I plug in 10, negative 5 times 10, that'd be negative 50. And negative 50 is less than or equal to negative 50. It's equal to. So that would be true. Okay, turn around. All right, next page. Negative 6 is less than 1/11th of x. How would I solve this problem if this was an equal sign problem? An equation. I would need to multiply both sides by 11 over 1 or 11. Now be careful. Sorry about the blurriness. There we go. Much better. Put on the focus. Anyway, so if I were to multiply both sides of the inequality by 11 over 1, notice I multiplied both sides by a positive value. I don't care that this negative 6 is negative. I did not multiply both sides by a negative number. I multiplied both sides by a positive number. Therefore, this inequality symbol is still technically true. So that cancels out the 11s. And 11 times negative 6 is negative 66. So negative 66 is less than x. I don't like it when x is on the right. That kind of confuses me. So I'm going to start the sentence with x on the left. If negative 66 is less than x, that means that x is greater than negative 66. So it doesn't have to be drawn to scale. You just have to put 0 in the middle. Negative 66 is way to the left. And all numbers greater than negative 66 means I put a circle on negative 66 and shade all the way to the right. And put a big old arrow to show that I'm going to infinity and beyond. Final question though. Is negative 66 included into the solution set? No. There is no greater than or equal to sign. It's just greater than. So all numbers bigger than negative 66, not including negative 66, are part of the solution set. All right, number 16. We've got 5 more to go. Negative 63 is greater than negative 9x. If this was an equal sign, what would I need to do to solve for x? I'm going to divide both sides of the inequality by negative 9. Cancels out. I get 7. However, notice that I divide by negative. Sign flips. So the sign flips because I divided both sides of the inequality by negative 9. So I'm going to turn this greater than symbol into a less than symbol. So 7 is less than x. Once again, I like it when x is on the left. So if 7 is less than x, start the sentence with x. 7 is less than x means x is greater than 7. No issue whatsoever. I'm going to put 0 in the middle. Positive 7 is to the right of 0. Put a big old circle on the endpoint 7. And remember, x is greater than 7, which means x is allowed to be any real number bigger than 7. This is a visual representation of that true statement. So all numbers bigger than 7 are legal. Anything that is not shaded is illegal. But is 7 itself included in the solution set? No, there is no greater than or equal to sign. It just means greater than. Okay, put this on the side for now. Now let's do 4 more problems. Back to addition, subtraction. Okay. 9 is less than or equal to x plus 2. Once again, subtraction and addition on both sides have no impact on the inequality symbol. Just to get some flexibility, if this was an equal sign, x plus 2 equals 9, what would I need to do to get x isolated? I'm going to subtract 2 from both sides. Knocking out positive 2 with negative 2, I get x isolated. 9 minus 2 is 7. So 7 is less than or equal to x. Now, I'm just going to rephrase it with x as the start of the sentence. 7 is less than or equal to x means x is bigger than, specifically greater than or equal to 7. And now, I just draw a little number line. There's 0 in the middle. 7 is to the right of 0. Put a big old circle on the 7. And all numbers bigger than 7 get shaded to the right with a big arrow at the end of the number line to show that it's going to infinity and beyond. Is 7 itself included in the solution set? Of course, it's invited to the birthday party, so shade it. Anything that's shaded gets invited to the solution set birthday party. Okay, number 18, 3 more to go. This time, 12 is greater than or equal to x plus 18. So I'm going to start the sentence. I'm going to rewrite the problem. If this was an equal sign problem, how would I solve for x? I would minus 18 on both sides to get x isolated. So 18 cancels out with negative 18, and 12 minus 18 is negative 6. Since subtraction has no impact on this inequality symbol, the sign stays the same. Negative 6 is greater than or equal to x. But now I'm going to start the sentence with x to make my life a lot easier. If negative 6 is greater than or equal to x, that means that x has to be less than or equal to negative 6. That is my solution set. And now I am going to draw a number line, 0 in the middle, negative 6 is on the left, circle the endpoint. All numbers less than negative 6 go to the left of the endpoint. And a big arrow to negative infinity and beyond. But is negative 6 itself included in the solution set? Yes. Less than or equal to means that the endpoint itself is included. 2 more problems and then we'll call it a day. Negative 3 is greater than x minus 13. If this was an equation, how would I solve for x? Oops, that's a typo. Sorry about that, guys. I don't want to confuse you. There we go. Here we go. So now, if I were to rewrite this problem, negative 3 is greater than x minus 13, I would add 13 on both sides. Cancel out the negative 13 with the positive 13. Addition has no impact on the truth, so it's still true. So that'd be negative 3 plus 13. That would be positive 10. And positive 10 is greater than x. Rewrite the sentence. Start the sentence with x. If 10 is greater than x, that would mean that x should be less than 10. Draw a number line. If 0 is in the middle, and 10 is to the right of 0, where do I shade? Circle the 10. X is less than 10, which means x is legally allowed to be any number less than 10. Shade to the left. And put a big arrow at the end of the number line. Finally, the last problem of the day. Negative 27 is less than x minus 12. All right. Now I'm going to add 12 on both sides of the inequality. Cancel out the negative 12 with the plus 12. And now negative 27 plus 12 is negative 15. Since it's adding on both sides, that has no impact on the true statement. So it's still true. Negative 15 is less than x. Now rephrase the problem with x at the start. If negative 15 is less than x, that means x is greater than negative 15. And that is our solution set. Last thing before we end this video. 0 in the middle. Negative 15 is on the left. I'm going to circle the endpoint. And I'm going to shade all values to the right. Okay. Is negative 15 itself invited to the solution set birthday party? No, so we keep it open. All right, that's the end of the video. In the next video, we'll talk about fractions multiplying to x, more than just 1 over 4, more 1/3. So what happens if we have 2/3 of x in the problem itself? How do we undo the layers of x? All right, have a good day.